In the series of multi-threading interview question, let's see how we can design the custom callable as shared in the previous video. So let's quickly jump how we can design our custom callable. So here I have designed a custom callable, pass the generic K. Basically, it will be the return type of the call method. I have implemented one implementation, which will return again the list. So in order to sync it with the earlier video which we have seen, you will have better clarity. Um, so like how we can return the data here. So this is the call method and we are returning a list, and that's why we have passed the generics as a list here. Now going to the custom future method, how we can design our own future method, which is most important one. So basically the custom callable initialization with the implementation, we can pass it here in the constructor, and then we can call that call method. This is the most important thing, like we can call that call method inside a synchronized block. So we have one flag which checks that the execution is finished or not. So if execution is not finished, it will be false, right? By default, the I am initialized by the false. By default, boolean variable, primitive boolean will be false since it's a data type. So I have initialized it with the false. Now this dot custom callable dot call, and I am calling the call method of my implementation. So it will go to here. Here it will go to the implementation method because I have initialized with that. So it will call this call method. Okay. And see, till that time, it will be false. And then it will notify. So what I am doing in the get method, this is important. Get method and call callable. I both synchronize this object. This will refer here to the future object, custom future object. I have already shared this concept, the object level lock and the class level lock in the previous video. Refer to that if you have any confusion regarding that. So here this will, if the object is same, if the object, again I will just repeat in short, if the object of custom feature is same, then the lock will be acquired. So either let's say object, there is a same common object. So if this has taken the lock, if somebody is operating in this synchronous lock, so no one can take this one. If this has been taken, no one can take this one. So here what I am doing is I am just checking, is the execution finished. So execution, if it's not finished, what I will do, I will go to wait. So before going to wait state, I will awake other sleeping threads. Hey, wake up, and it will awake other sleeping threads. So let's say it's the main, the other thread is waiting for this callable. So other thread, let's say, is waiting to execute this block. So it will just notify that, and it will start, it will wait here. It will go to the wait state, means it will reach, it will stop the execution from here. So I will just run and show this how this will work. And then once it is finished, again this will notify, since this thread was sleeping, it will notify and it will start from here, and it will return the data. So that's how it will work. Okay. So the main key point is, like, we will both synchronize get and this, and if execution is not finished, we will just notify and we will ask the thread which is called the get method to wait. And once it is done, we will it will notify again and it will start from there and it will return the data. So that was just the small trick using the wait, notify, and synchronize. Now let's try to run this. I will call the internal execution. So here I have created this custom callable implementation object. I have passed it into the custom future, and I have started that thread, and here I will wait for the response. So let me run it. See, so first it start executed get method. So get method, what will happen? Is execution finished is false. False. So it will go to notify all. It's though not required to notify because other thread is not sleeping, it's in running, but it's waiting to get the lock. Here it's waiting to get the lock. So yeah, now it will wait. See, it will wait. Now let me check if there is, yeah, there is a debug breakpoint. So see, it came here, it called the call method, execution finished, and now it will notify all, and then it will return the data. So yeah, see, it's returned the data. If let me make it bigger, see, we are getting the data. So if I put a breakpoint here, and let me put a breakpoint, let's say here, we will see it again. Once it will notify all here, it will come to this return data again. So let me run it again one more time. Internal execution. See, it came here. Execution finished. No, it's not finished. Let me jump to the next. It went to wait. It went to wait. It released the log. Callable executed. It fetch the data. Execution finished true. Notify all. It will just notify all. It has released the log. Right now, see, it came back to return data. Data size is 100. Sorry, the multiple of 1000 into 1000. Okay, so yeah, let me complete it up. So this is the trick or the hack how we can design our callable. We can make a boolean flag, or we can just check with the null if the data is null. We can make one get method. We can check if it's not finished. We can put it into wait state. Once it is finished, we can notify, and it will start the execution from there, and it will return the data. This was the hack. If in case someone asks you to design the callable also in the future also, feel confident to design both of them. The GitHub link will be there in the description. You can refer the code from there. Have fun. We'll see you in the next video.